Okay, pre-calc fans, today we're going to be starting talking about what's called asymptotes. Okay, you heard about asymptotes last year, I think, when you talked about exponential equations and log equations, when you talked about their graphs. All right, we have more to do with asymptotes this year. Okay, so first of all, rational function is a function of the form r of x, r for rational, p of x over q of x. So p is any polynomial, q is a polynomial, where p of x and q of x are polynomial functions, and the degree of q of x is at least 1. Okay. So the definition of an asymptote, it's a line that we approach and get very close to. Now, there are some asymptotes that we never hit or never cross, and there are other asymptotes that we can cross. Okay? So, the first one we're going to talk about are vertical asymptotes. A vertical asymptotes, those occur when the function is undefined. Okay? So when q of x is equal to 0, that's your denominator is equal to 0. Therefore, if a is a 0 of q of x, then x equals a is an asymptote. Now notice it says x equals a. What do we know about the lines x equals? That's right, those are vertical lines. Okay, an x equals line, x equals a constant, is a vertical line. Vertical, 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 up and down. Okay, these vertical asymptotes we never cross. We can never cross, cannot cross a vertical asymptote. Okay, so right now what we're going to do is we're going to look at 3 examples, and we're going to state the equation of the vertical asymptote, or asymptotes, it could be plural, of each. That's right, so when is this function equal to 0? When is the denominator undefined? When is the denominator undefined of the function? When is the denominator equal to 0? That's right, at x equals negative 6. So this is a vertical asymptote at x equals negative 6. It's literally just set the bottom equal to 0. That's right, we'll set this bottom equal to 0. That's right, you factor it if you have to. So the vertical asymptote here is x equals plus and minus 4. This is the vertical asymptote. That's your vertical asymptote. Vertical asymptote. Vertical asymptote. Okay, what about this one? When's this denominator equal to 0? That's right. X squared plus 25 will never equal 0. Therefore, this equation has no vertical asymptote. Okay? That's right. X squared plus 25 will never equal 0. Okay? If you tried to, that's right, x squared equals negative 25, so x would equal plus and minus 5i. This is imaginary. We're only talking real numbers. Okay, so this bottom will never be 0, so this has no vertical asymptote. That's okay that we don't have a vertical asymptote. Nothing wrong with that. Okay, horizontal asymptotes. Horizontal asymptotes is when we talk about the end behavior of a graph. Okay. And horizontal asymptotes we're allowed to cross. We may cross horizontal. In these equations, we can cross them. So we may cross these vertical asymptotes. Okay. Now, when we talk about the end behavior, this is what we talk about. The idea is this: as x is getting big, and I mean very, very, very big, as x gets closer and closer to infinity, all polynomials 10 to their first terms. Okay? So then we're asking ourselves, what the heck happens to the y value? So as x is getting bigger and bigger and bigger and bigger, what happens to the y values? Okay? What happens to y's? Okay? And this concept as x is getting very, 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 very big is called a limit. So when y is equal to the limit as x goes to infinity, LIM stands for limit. You'll learn about that. We talked about limits before already, briefly. So here we're using this word again as the as the rational function r of x. As x goes to infinity, what happens to the y value? This is what I mean by when x is getting very, very big. Okay? All right, so let's look at these groups here. The following functions are grouped according to what type of horizontal asymptotes they have, if any, and according to the relationship between the degrees of p of x and q of x. All right, so let's look at group 1. So group 1, as x is getting big, okay? Remember, everything that we talk about is x gets big, what happens to the y? So let's look at this first equation. As x is getting very, 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 very big, okay? Look at this equation. What happens? Okay, so let's think like x is a billion. So you got a billion minus 4. Well, you minus 4 from a billion, let's just call it a billion. So we're talking about 2 over a billion. What is that fraction, 2 over a billion? That's right, that's really, 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 really small. So it's so small that we can just say the horizontal asymptote would be y equals 0. Okay, so as x is getting very, 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 very big, the y value is getting very, 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 very small. So small that we say it goes to 0. So this has a horizontal asymptote of y equals 0. Okay? So I'll write it over here on the side. As x gets big, y gets small. Okay? And in this case, y is so small, we just say it goes to 0. Okay? Let's look at this next one. Let's use a billion. 5 times a billion minus 3. Do you really care that you subtracted 3 from a billion? From 5 times a billion? No. You don't even care about the minus 3. Okay? Now look at this. We have a billion squared minus 3 times a billion. And if you square a billion, that really has a lot more power than minusing 3 times a billion. So we don't even care about these terms right here. Okay? So this is literally what we're looking at. 5x over x squared. What happens when you reduce that? That's right, that simply equals to 5 over x. And again, let's talk about, so remember, as we're looking at 5 over a billion, remember I said x was a billion? Well, 5 over a billion, that's just like this. It's very, 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 very small. So we just say it goes to 0. So this is another y equals 0 for a horizontal asymptote. And this is what we mean by, as x gets big, all polynomials tend to their first terms. Okay? You know, you do 5 times a billion minus 3. Minusing the 3 from a billion doesn't matter. It's still 5 billion. Okay? A billion squared has a lot more value and power than 3 times a billion. Okay? Okay. So let's just look at this then in terms of the terms. So as x is getting big, we don't care about these other exponents. All we care about are the leads. That's it. 3x squared. We could care less about this. 2x to the fourth. We could care less about the last parts of it. So now we're looking at this. 3x squared over 2x to the fourth. Right? If you want to simplify it, you can. So you're left with 3 over 2x squared. Same thing. You know, as x is getting bigger and bigger and bigger, what happens to this fraction? That's right, it gets smaller and smaller and smaller. This goes to 0. Okay, y equals 0. Okay. All right, now let's look at an equation that's in factored form. Okay, I'm still going to do the same things, but really I'm just going to multiply my x's. X times x gives me an x squared. I don't care about everything else. Remember, we're only talking about the asymptote here. What happens was x is getting bigger and bigger and bigger. Okay, all I care about is x squared, x times x. Here I have an x squared times an x squared, so I have an x to the fourth, right? And this reduces to 1 over x squared. So this still goes to y equals 0. Okay, now look at all this grouping right here. Remember how it says the relationships are, look at the degrees of the equations. What do you notice about group 1? In group 1, what do you notice about? Some of them had a constant at the top, but also look at the degrees. This is a 0 degree, this is a first degree. Here's a first degree, here's a second degree. Second degree over a fourth degree. Here's a second degree over a fourth degree. That's right, the degree at the top is larger than the degree at the bottom. So right here in column 1, I'm going to write a fraction bar. Degree on the top, at the top, is big. Degree at bottom is small. Those become y equals 0 for our horizontal asymptote. So whenever the degree at the top, ooh, why did I put big? Degree at the top is more. Degree at the bottom is less. I did it again. Oh my goodness. So the degree at the top, here's my fraction bar, small. Degree at the bottom, big. Those go to 0. Wow. So the degree at the top is smaller than the degree at the bottom. Those go to 0. Horizontal asymptotes, y equals 0. All right, let's look at these. All right, as x gets bigger in group 2 now, as x is getting bigger and bigger and bigger, all we care about is the lead. There's 5x, and all we care about is the x. Look at that, 5x over x. It's right, that reduces to just a 5. So this actually has a horizontal asymptote, y equals 5. As x is getting bigger and bigger and bigger and bigger, this equation is getting, y's are getting closer and closer and closer to 5. Okay. All right, look at this one. That's right, all we care about are the leads. All we care about is the lead. So I have 3x squared over 4x squared, which is 3/4. That's right, those cancel out. So we have a horizontal asymptote, y equals 3 over 4. So now, yeah, these horizontal asymptotes are constants that are not 0. Okay? There's some constant that's not a 0, but still a horizontal line. All right, what do we know about the degrees here? All right, this is a negative 5x cubed. We don't care about this, and 10x cubed. All right, so this reduces to negative 1/2. A horizontal asymptote, y equals negative 1/2. Okay. Let's do some cleaning. I got a 4 and a 6 here for a reason. So I have 4x squared at the top, and we have 6x squared at the bottom. So this reduces to 2/3 for a horizontal asymptote. All right, what do we notice about the degrees at the top and the bottom? That's right, the degrees are the same, and it goes to a constant. Okay? So group 2, degree same top and bottom. So the degree at the top of the fraction, the degree at the bottom of the fraction are the same, and so that becomes y equals some constant. Okay, y will equal a constant. It's a horizontal line. All right, group 3. That's all right, x squared over x reduces to x. Is this a horizontal line, y equals x? That's right, that's not a horizontal line. Not horizontal. So therefore, no horizontal asymptote. No horizontal, not horizontal line. Y equals x is not a horizontal line. All right, what about this one? All right, this is 2x cubed over x. 2x cubed over x when we ignore everything else except for the leads. So that's just 2x squared. Is 2x squared a horizontal line? No, it is not. Not horizontal line. Okay? And the same thing right here. Yes, we're back to the same thing. We're left with, when you clean those up, you're left with 3x. Not horizontal line. So what did you notice? For the degrees, right, the degree at the top is larger than the degree at the bottom. So degree top more, degree bottom less. No horizontal. Okay? Because when you reduce them, they are not horizontal lines. This is an oblique line. This is a parabola. You'd have a parabolic asymptote on the ends. Okay? That's right. So when you looked at your groups here, I'll fold it over this way. So when you looked at your groups, group 1 had horizontal asymptotes of y equals 0. Group 2 had a horizontal asymptote of y equals some constant, and that k was not 0. K stands for constant. Okay. And then in group 3, there was no horizontal asymptote. Okay. And what did we notice about the group 1 degrees? That's right. Degree top, small. Degree bottom, large. Okay. These had the same degree. Top and bottom. And the last group, degree at top, larger than degree at the bottom. Okay. Okay. All right, now the last piece is that we need to talk about is what's called a slant asymptote. A slant asymptote is literally a slanted line, not a horizontal line, not a vertical line. Horizontal, vertical, slant, a diagonal line, okay? Or else it's also known as an oblique line, okay? The slant asymptote, or the asymptote is an oblique line. The degree on the top is one more. That's very, very important. It's got to be one more than the degree at the bottom. Okay? You actually saw two examples on the other side. This degree at the top was one more. So notice we had the starting of a oblique line, y equals x. And the same thing down over here, y equals 3x. But there's more to it. There's more to it. That's what we have to talk about. Okay? We have to do long division in order to determine the slant asymptote. Okay? So, if this is a second degree, this is a first degree, I could do synthetic division here to create our equation. So 3, -2, -1. Drop the lead. So there's -12, -14. And actually, we don't even care about the remainder. There is your slant asymptote. Y equals 3x minus 14. Okay? Now, if I did this with long division, it would have looked like this. 3x squared minus 2x minus 1. You do not care about the remainder. All you care about are these two terms right there. So x times what is 3x squared? Okay, that's right, 3x. So I'll put the 3x here. So 3x times this, so it's 3x squared plus 12x. And then we subtract, gives us a -14x. X times what is -14 minus 14. You do not care about the rest. This is all you care about. So y equals 3x minus 14 is the slant asymptote on this problem. Oh, so you can't do synthetic division here. Look at this. We have a third degree equation above a second degree equation. One more than the bottom, so it's certainly a slant. We just have to do the long division. This will be interesting. Look at this. Just because I'm using three terms here does not mean we freak out. No, the rules are exactly the same. All we care about is the first term. All right, I don't need any placeholders on this problem. And all you care about are the last two terms. X squared times what is 2x to the third? That's right, 2x. Where does that go? That goes right above your x. Then what do I do with the 2x and this? That's right, we multiply. So it's 2x to the third minus 2x squared plus 2x, and when we subtract. That's right, you got to change all your signs. So minus, plus, minus, cancels. This is a plus right here, so we had what? Negative 1x squared. That's a minus, so minus 1x, and then I bring down the minus 2. All I care about is this term right here. I could care less what this multiplies out to. So x squared times what is a negative 1x squared? That's right, negative 1x. Just negative 1. There, I don't care about what's under here. This is all I need. We could care less what goes right here. Whatever you want to write, does not matter. Okay? Don't need it. Do not need. This is all we need. Y equals 2x minus 1 is the slanty asymptote. Okay? All right, folks. That's our little lesson on asymptotes. You'll see the homework in Canvas. Enjoy.